We're doing moles to grams or liters stoichiometry. That means we're going between two substances and we're going from moles of one substance to moles of another substance and then converting it to the units that are requested by the problem. Okay, so I am going to do the rest of the problems with you. 1 and 2 is done on the video. The first thing you have to do, number 1, is balance the equation. 3 goes there and 2 goes there and we're balanced. Then it says to ID the unknown and given. So I blew this up, so I'm missing some of the words, but it says how many grams of ammonia. So I'm looking for grams of ammonia, so this should be directly under ammonia, can be produced from 0.95 moles of nitrogen gas. And I'm starting at moles, so we need that, and I'm going to grams of substance B. So let's look at our mole island and see what our path looks like. Substance A, the one that I'm given, is N2, and I'm going to ammonia, NH3, okay? And I'm starting with 0.95 moles, and then I want to go to moles of ammonia, and then ultimately I want to end up at grams of ammonia, question mark grams. So there we go. So our path is starting at grams of NH3. That's our given number. I'm sorry, not grams. Let's start that again. We're starting at moles of N2. That's our given number right here. And we're going to moles of substance B, which is NH3. So I'm going there. And then I need to convert that to grams of NH3, which is ammonia. So when I write this out, I start with my given, which is my moles of N2. So 0.95 moles of N2. Okay, now I don't want to stay on mole island. I want to get off of moles of N2 island, so I put it on the bottom. And where am I going to next? Moles of NH3. And whatever here's on top is where I want to go next, and that should match your path. Okay, so then do I want to stay on this island? That is not my end. We said my end was here, so I have to get off of moles of NH3. I put it on the bottom, and I'm going to grams of NH3 right down here. Okay, so now let's check this. Moles of N2 is gone, moles of NH3, and I'm left with grams of NH3. That's what I'm solving for. Life is good. Here's my mole to mole ratio. That's between here and here. That says to use the coefficients from the balanced equation. NH3 is up here. That coefficient is a 2. And moles of N2 is right here. That coefficient is a 1. And then here is where I see people putting in a lot of strange numbers. First of all, sometimes they have it going to the wrong path. Double check your identifications of where we're going to and make sure you're solving for NH3. Okay, and now I am going from moles to grams. And on your original mole island, you have these conversions there. 1 mole is how many grams? Well, I get that from the periodic table. So 1 goes with moles right here, has nothing to do with coefficients. It's how many grams are in 1 mole. And on your worksheet, I added up ammonia, which was 17.04 grams. So when you put that into your calculator, you may get a number you have to round, 0.95, multiply by the top, divide by the bottom, okay, times 2 equals, divided by 1 equals, times 17.04 equals, and we have 32. We have 32.376. Now I have 2 sig figs here, so I want only 2 sig figs. That 3 doesn't round it, so I have 32 grams. That is my units, and then I need my chemicals. Grams of what? Grams of peanuts? No, grams of ammonia. So now we're on problem number 4. Again, you have to balance. If you don't have a balanced equation, you can't do the right coefficients. And then we have to ID. I'm given 8.6 moles of hydrogen gas. So 8.6 moles. And they asked me to find blah, 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 how many liters of ammonia gas? Question mark, liters at standard temperature and pressure. So I'm not starting at nitrogen anymore. I'm starting at hydrogen, and I'm starting at moles with 8.6 moles, okay? And then I'm going to moles of ammonia, but they don't want it in grams this time. They want it in liters. So I'm going to here, okay? So I'm going from moles of hydrogen. My next step is moles of ammonia. And then I'm going to liters of ammonia. Okay? So what do we start with? Our given number, which is 8.6 moles, I should put a 2 there, of hydrogen gas. Okay? So I don't want to stay on mole island of hydrogen gas. I need to get off of it, moles of hydrogen, and I'm going to moles of ammonia. And so these guys cross out. And now this number doesn't get brought down here. No, this comes from the coefficients from the balanced equation. NH3 has a 2 and hydrogen has a 3. And now I'm not done. I don't want to stay on this island. I want to get rid of moles of ammonia. So I put it on the bottom. And I want liters of ammonia. And so where do I get that number from? Well, that comes from our one-step conversions going from moles to liters. One goes with moles and 22.4 goes with liters. So one goes down here and 22.4 go up there. So now when we plug this in our calculator, multiply, divide, multiply, divide, we get 8.6 times 2 equals divided by 3 equals times 22.4 equals divided by 1. And what you get is 128.4 blah, 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 blah. I have two significant figures in my given. I'm going to underline those two. The 8 does round it to a 3, but this is a hundreds number, so it has to stay in the hundreds. So I get 130 liters of ammonia. Okay? Now we are on number 5 and number 6, and I am not going to label this anymore. I'm just going to use this to show you your path. So we are going to start out this problem with 5.3 moles of sodium chloride, and I need to find grams of iron chloride needed. How much do I need to produce that much? So we are going to start with moles of NaCl. We are going to moles of FeCl2, and then I'm going to grams of iron chloride. Okay? So we write down our given first, which is 5.3 moles of NaCl. And I'm on this island. I want to go to moles of iron chloride, and then I'm going down to grams of iron chloride. So moles of A to moles of second substance B, and then to the units they want. So I want to get off moles of NaCl. And I want to go to moles of B, which is moles of FeCl2, iron chloride, and those cancel out. But I don't want to stay on moles of FeCl2. I put it on the bottom to get off that island. And I'm going to grams, because that's what they asked me for, grams of FeCl2. Okay, so mole to mole ratio, where do we get those numbers? From the balanced equation. And oh, I haven't balanced it yet, so let's see. 1 iron, 2 chlorines, 2 chlorines, and then 2 sodiums, and that gives me 2 hydroxides, so now I am balanced. So FeCl2 is 1, sodium chloride is 2, okay, and now I have my gram to mole conversions, grams to moles. It's how many moles per gram. And remember, that's on your one substance mole island, but you can add it right here. So for every 1 mole of iron chloride, I've done the molar mass here, I get 126.75 grams, okay? And this is all from your periodic table. 1 iron, 2 chlorines, add up every atom together. And then what you are going to end up getting is, when you put that in your calculator, rounded to sig figs, is 340 grams of iron chloride. Okay, so remember, 1, 2 sig figs, that other guy may round that, and that's why we got 340 instead of exactly what your calculator said. So the last problem, we have 0.053 moles of iron hydroxide, 0.053 moles of iron hydroxide. How many grams of iron chloride? So this is under my iron chloride. That's iron hydroxide. I'm starting at moles of substance A, which happens to be moles of FeOH2, iron hydroxide, and I'm going to moles of substance B, the moles I'm solving for, which is moles of FeCl2. And then they want to know how many grams of iron chloride are produced. Okay, so I am going to grams of iron chloride. Okay, so we start with our given, our moles of iron hydroxide, which is 0.053 moles, okay, of iron hydroxide. I don't want to be at moles of iron hydroxide. I want to go to moles of iron chloride. Okay, and so I'm here, but I don't want to stay on moles of iron chloride island. I want to get off there and go to grams. How do I do that? I put it on the bottom, and I go to grams of iron chloride. So here I have a mole to mole ratio, moles to moles, from the balanced equation. Don't forget to balance that. So iron chloride is 1 and iron hydroxide is 1, so that's not going to change. And for every 1 mole, I have 126.75 grams of iron chloride. That's this one substance conversion here. Okay, so when you put that in your calculator and round it to the correct sig figs, you're going to get 6.7 grams of iron chloride. And please make sure that you put that in your calculator and you know you're getting the right number. Multiply, divide, multiply, divide. I have a lot of people who go through this, they just write the answers and then they miss all the questions on the quizzes and tests. Make sure you know how to work that calculator and make sure you know what you're multiplying and dividing by.